Web security, like everyone's leaving? Everyone's leaving? Well, I should have the quiz at the end of the class. Yeah. So we have one more quiz, and I will make it the last part of the last class, so everyone can be here. Okay. Okay. So let's continue the discussion on web security. So like we explained last week, web is a very complicated system. First of all, it's distributed, and usually at least there are 3 modules involved in any web application. First is a browser and the client-side script, usually JavaScript, running on top of browser, and the server-side script, PHP or other languages, could be Java, and they're usually also a database. And all of those 3 modules, they run some kind of a code. So CQ, you can consider that is a query language. You can consider it's a code. And the server side, they run PHP, and the browser, they run JavaScript. So all those code, they are subject to code injection attacks, which means you can inject some malicious code to the client side on the browser or on the server or to the database. So code injection is actually a very serious attack. It allows attacker to run arbitrary code on the victim's machine. And you may heard buffer overflow before. So buffer overflow is one type of code injection attack that attacker can inject some binary code on the program stack. And but in web applications, there are at least 3 attack surfaces we can inject malicious code. So the root cause of all the code injection attacks, they are the same. So basically, the reason is we cannot separate what is code and what is data. You may think that's very simple, but actually, it's a very difficult task. So because code is data itself too. So and usually code and data, they are sharing the same channel. So when a victim environment, it could be your host program, it could be your browser. When it receives some kind of a byte string, it thinks this is benign data. But actually, when it interprets it, it may use it as some code, and that code can be malicious. So in buffer overflow, what happens is the program will first push some malicious, but it thinks it's benign data on stack. But when it pushes that on stack, that data will overwrite the return pointer on the stack and also put other code there. Then later, when that function, which is injected, returns, it will return to the injected data. But that data can be interpreted as malicious code. So this problem, the code injection problem, and the problem of separating code and data is fundamentally difficult, very difficult. So recently, I think this is maybe 4 or 5 years ago, someone published a paper in one of the best security conference. The paper is called English share code. So share code, first of all, share code is a very small piece of code that is used to exploit a system. So if your system has a bug, the share code is trying to exploit that bug. And this share code usually is very small, only 200 bytes or even less. And in this paper, they invented a new way to generate share code, which makes share code look exactly like plain English. So all the signature-based IDS or antivirus, also alumni-based IDS or antivirus, do not work anymore because they are not using anything special, anything you can use as a signature. So imagine it's just a plain text English. How can you use that as a signature? It could be just someone chatting with you. So here is an example. So this is a paragraph of just a regular English. It doesn't read like, it's not very beautiful English, but it's readable. It's really English. But this English can be interpreted as shellcode. And this shellcode can do something actually malicious. So that's why the problem of separating code and data is fundamentally difficult, almost impossible to do. So if we go back to web security, and we are talking about injecting, so we can talk about 3 ways to inject code to a web application. The first one is the client side. We can inject some JavaScript code. So JavaScript allows the web developers or web creators to run the code they want to run in user's browser when a user visits their website. And the JavaScript, usually they can manipulate the web pages, and they can manipulate cookies, and can send out requests. So technically, it can read the cookies of this website and send it out to other websites. So in a typical browsing behavior, it consists of loading a web page, then select some actions that we want to do, like maybe filling out a form and submit the information. So this is where we really need JavaScript, and there is one application called AJAX we can utilize to make this experience much more smooth for us. So in the old web page, we have to click the submit button. But if we have AJAX, the AJAX can, so the old website, when you send out that message, it will be in this case, we didn't specify. This is a post or get. So I think it's a HTTP get. So this input will be, this is HTTP get, right? We didn't specify that, that's why. I think get is default one. Yes, yeah, default is get. So this will be a HTTP get message to the web server. Then the web server will return this message, will return a website back to us saying the website already received this message. However, by doing this, your browser is reloading that web page. And that website is also sending out a new page to your browser. So, but we only need a very small part of the web page updated actually. We don't need to update the whole page. We don't want that. So that's why we have AJAX. So AJAX is a means of using JavaScript to communicate with the web server without submitting a form or loading a new page. So usually it uses a built-in browser object called XML HTTP request. So actually the technology was invented by Microsoft. So it was introduced in IE first. So IE, they use a different object, but all other browsers like Chrome or Firefox, they all use this object. So AJAX stands for asynchronized JavaScript and XML. So here we're not using HTML because when you do a AJAX request, you are not requesting a full web page. You are only requesting some data, and usually that data can be returned in the format of XML, not HTML. So the word asynchronized means the user is not left waiting for the server to respond. So the user can do other things in this web page, but only a part of this web page is requesting new data from the server. So for developers, if you want to use AJAX, you first use JavaScript to create this XML HTTP request object, and you use this object to send a asynchronized request to the web server, and the web server will respond by sending the content of file or whatever. And when this response arrives, the browser will notify your JavaScript code that I already received this asynchronized request, and your JavaScript, usually the developer will develop a callback function, and that callback function will be called by your browser to handle this request. So one way, so you see JavaScript is very important. AJAX is very important. So all the websites we are using now, they use JavaScript. So if you want to stop a JavaScript injection, so one way to do that, a very simple way, is you just disable JavaScript on your browser. So all the browsers we have, they offer this option. So you can just simply disable JavaScript. I think this is Chrome, so you can disable JavaScript there. So, but if you disable JavaScript, you are losing some functionality of this website. So it's not really a very good option, and even Chrome here, you said it's not recommending you to disable your JavaScript engine. So, but attackers, they can inject malicious JavaScript. So basically, the technique is called cross-site scripting. And this technique was discovered around the late 1990s, right after JavaScript was introduced. So the basic idea is attacker wants to inject a malicious JavaScript into the web page viewed by the victim user. So this JavaScript can run in the user's browser and with access to the page's data. So we started the same origin policy before. So the same origin policy says that a JavaScript from site A can only access the data, including the cookies and the web pages, from site A. It cannot access or manipulate the web page cookies from site B. But the same origin policy cannot stop this cross-site scripting technique because when you use cross-site scripting, the attack actually happens within the same domain, same origin. So basically, the attacker needs to somehow trick the server. In this case, the server could be a bank, could be a forum, to send some malicious script as a user. So when the user's browser receives this script, it believes this script is coming from the legit bank or the forum, not by any attackers. But actually, it was injected by the attacker in the first place. So there are two basic types of cross-site scripting. One is called reflected cross-site scripting. In this kind of a cross-site scripting, an attacker gets users to click on a crafted URL, and that URL will include some script. So when the user clicks that URL, it brings the user to the website and also retrieve the web page from that URL. But also there is already a script included in that URL. So the user's browser will believe that script is also part of the website, which is not true. So this reflected cross-site scripting is easier to defend. Basically, you can just disable all those scripts in the URL. We will show a more detailed example later. So the second type is called store, the cross-site scripting. So in this type of cross-site scripting, the attacker leaves JavaScript on the beeline web server. So the attackers can inject the JavaScript in maybe the website's database, or if it's a forum, it can be in the content of the forum. So here is an example how the reflected cross-site scripting works. So first we have an attacker, we have the victim's browser, and we have another website. So first, the attacker will send out a malicious URL to the victim. So you see that in this URL, not only we have the domain name, the path, we also have some script here. So we have some script here. So the user, so when the attacker sends this to the user, it could be just some instant message, could be email, it could be all other ways to send out this URL. Then when the user clicks this URL, the user's browser will bring the user to this website. So the second step, the user's browser will visit this website. So this website is not malicious. Everything here is benign. And this website returns the web page and the 200 OK to the browser. The browser will try to render this web page. First, it will put the web page returned by this website here in the browser, and also it will put the script in this web page when it renders, because it believes this script is from the website, but actually the script was provided by the victim's browser, not by the website. So in this case, the browser will mistakenly believe this is from the website, and so this piece of code can access everything from this website, because the browser believes they are from the same origin. So everything means cookies can manipulate the web pages. If this is a BAX website, which means this piece of script can read your bank account information and send out another HTTP request, maybe to the original attacker. So in this case, in this example, this piece of code tries to steal the cookies and send those cookies back to the attacker. So attacker can use this cookie to log in to the victim's account. So this is how reflected cross-site scripting works. Any questions? Yeah.
So let's say there's like a limit on the characters that you can put in the URL.
Yes.
If you hosted the malicious JavaScript remotely and included it as a remote reference in the URL, would it not work for getting cookies because it's on a different domain?
So when your browser retrieves that, they will consider that from the same domain, probably.
It would be like script source tools and then like a different URL.
Probably they were things that are the same domain. Yeah. I'm not sure, because every browser treats that a little bit differently. Yeah, I'm not sure. I will check that. So you can see that one way to stop this kind of reflected cross-site scripting is anything in the URL, if it's a script, we will just consider it as that, not script. Yeah.
So is the scope of the consequences of an attack like this restricted to browser operations, or can they download malicious content onto your computer as well?
It could be. It depends on what this script trying to do. That script can try to steal your cookie, send out to an attacker. It can also try to exploit another vulnerability in your browser. So usually browsers here is the recent systems, they already deploy all kinds of defense mechanisms to stop buffer overflow. But recently, maybe 5 years ago, they find out they don't need to override the program stack, the browser stack. They can override the browser's heap. So they use something like malloc to generate a lot of garbage and source code there. But eventually, there will be that the code on the heap will be triggered. So there are also some defense mechanisms talking about that too. So in short, based on what the script wants to do, and but that requires another level of attack. attack the browser itself.
So is an attacker pretty much just going for some open port that might have a server listening and somehow finding some way of injecting that code to put it on the stack?
So in this kind of reflected cross-site scripting, attackers, they just send out the URL to you. Maybe through you're chatting with him, he sends you a malicious URL. It's very simple like that. Or he can post some malicious URL on a forum, and if you click that,
That'd be like the easiest thing. Now, how do they get the code into the benign website?
so in this kind of reflected cross-site scripting, they didn't really put the malicious code in the benign website.
Oh, okay.
They put it in the URL. The code is directly in the URL. So the other way is to put the code in the website. And there are many ways to do it. First, if the attacker takes over that website, they can do whatever they want. And a lot of websites, they allow users to post things. For example, like a forum, they always allow you to post whatever you want there. But if you post some script there, the website doesn't care. But when it goes back to any user's browser, the browser will maybe interpret that script. Yes, but the website thinks that it's just spam. I don't care. Okay. So that kind of attack is called a stored cross-site scripting. So basically, the attacker somehow manages to store that script on a website server. So it could be back.com, it could be any forum, and the server will just send that script to the victim's browser, and the victim's browser obviously will believe that it's from the legit website. So the browser will run that script and do whatever that script allows the website to do. So this is a detailed. So first, the attacker will somehow inject some malicious script to the website, and it could be, if this is a forum, then maybe just by posting some message. And then when the victim go to that forum or click go to that forum and retrieve the web page, and that web page has that JavaScript code that user's browser will interpret that part of the JavaScript code and considering it from this legit website. Then that piece of code can do the same thing as we discussed before. They can steal cookies, or they can try to exploit another level of vulnerability. So this is how attackers can inject code to the client side. And also another one very popular is SQL Injection. Maybe you've heard this before. So basically, in this kind of attack, the attacker tries to inject some SQL queries to the database. So basically, this is what a web application looks like. So usually, the client side of the browser, when you click anything, it will generate a query, and usually that query will have some arguments. So based on that's your input, and the server will construct a query based on this argument, and then then send it to the database. Then the database will do all kinds of query operations like insert, like select, and retrieve some data from the database, then send it back to the web server. Then the web server will build the web page based on the returned data. So the language to query the database is called SQL, and I don't know if you already took the database class. So SQL, there are several commands, like select is the way to retrieve the information you want from the database, and there are others like insert to add data to the database, and also drop to delete a table in the database. And you can actually issue multiple SQL queries at the same time by separated by this semicolon. So here we have insert, then we have select. So this sometimes is very important because for attackers, when we want to inject something, we have multiple steps, and the query language gave us the option to do that. So here is an example of SQL injection. So suppose that this is a website code. So the website, this is a PHP code. So first, the PHP code retrieves user from the post message. So this user part is what you as a user to send to the web server. Then it will construct a SQL query based on this user. So it's select account from the customer table where username is the username you sent. Then it will execute this SQL query. So if you just insert some legit username like Bob, so the SQL query will just look like this. Nothing is wrong. Select account from customer where username is Bob. So this is totally benign. But if attacker inject something like this, like a full or one or 1 equals to 1 to this query, then the web server will construct a query like this. So now, if you look this carefully, the where part would be where username equals to full, and it can be anything actually, or 1 equals to 1. So this whole clause will always be true because the attacker injected 1 equals to 1 there. Then previously maybe attacker can only get the account information of Bob, but by doing this, the attacker can get the account information of everyone, the whole table, so which maybe he doesn't have access to. So this is basically how SQL injection works. And the last type of injection is to simply inject code on the server side. So, so PHP and also other languages, they want to make the website more flexible. So they offer all kinds of functions. One of them is called eval. I guess it stands for evaluation. So basically, you can send out a string to the web server, and the web server will treat that string as code. So if the web developer is not careful, you can run whatever code you want to run there. But if a web developer they want to offer some functions like this, they should limit what kind of code they allow you to run there. But a lot of web developers, they make a mistake. They simply take what you gave them and just run it. So it could be anything. And another example is a PHP function called a system. So basically, this function can create a process on the web server, and that process can be anything. In this example, this PHP code retrieves the email address and retrieves the subject from the form you submit. It tries to send out an email for you. But what attacker can do this is, so this email and subject, they are supposed to be data, not code. So in this injection, the attacker can post the email address as his own email address, and the subject as full of redirection and a file name. So if we put this into the system function, the system will read whatever file you put there and use that as the subject of that email and send that email back to the attacker. So attacker can steal whatever file on the web server. in this case. Any question? So basically, these are 3 types of code injection for any web applications: the server side, the client side, and the SQL injection. And the web is really a very complicated topic. The web security is also a very big topic. I think Dr. Adam Dupe, he offers the software security class in which he spent a lot of time on web security, because web is very, very unique. So if you are interested in web security, you can consider take that class as well. Okay. Any other questions? Okay, then let's stop by here. See you guys next week.